So if we're going to understand integration, the first concept that we sort of have to introduce here is the concept of an antiderivative. And antiderivatives, well, they're almost exactly what they sound like. They are the opposite of a derivative. So over the past couple of months, we've learned a lot of rules for taking derivatives. To find antiderivatives, we want to apply those rules in reverse. But first, let's look at the definition here. A function, capital F at x, is an antiderivative of a function, small f at x, on an interval if, when you take the derivative of capital F at x, you get small f at x. Okay? For all x on that interval. Okay? So we could also put it this way: f at x is the derivative of capital F at x if f primed at x equals small f at x. Okay, so if taking the derivative of some function, function A, gives you function B, that means that function A is the antiderivative of B, and that function B is the derivative of A. So for example, if we've got f at x equals 2x, our antiderivative of this, capital F at x, would be a function like x squared. Because if we take the derivative, derivative of capital F at x is d by dx of x squared, we end up with 2x, which is f at x. Okay. So the antiderivative of small f at x equals 2x is capital F at x equals x squared. But it's not the only antiderivative. Capital but here. We could have chosen a function for capital F at x like x squared plus 10. If we take the derivative of this function, f primed at x is going to be 2x, and the 10 goes away because it's just a constant. Derivative of a constant is also 0. So the derivative is also an antiderivative. Say this. Derivative. So when taking the derivatives, we started with a function, we took the derivative, we got one function that was the derivative of the function that we started with. When doing antiderivatives, we can have, well, an infinite number of functions that represent the antiderivative to the function that we're interested. We could have easily had something like, f at x equals x squared plus 2,000. Any constant we add on there is just going to go away when you take the derivative. So sometimes we say that the most general antiderivative of a function, or in this case our specific function f at x equals 2 at x, is capital F at x equals x squared plus c, where c is a constant. So we can always add a constant onto the end when we are taking our antiderivative and still have a valid antiderivative.